This video is for educational and relaxation purposes only. Now, take a deep breath and settle in for a journey into the world of slow science. One of the slowest scientific experiments ever is the pitch drop experiment, started in 1927 by Professor Thomas Parnell in Australia. It involves pitch, a substance that seems solid but is actually a very slow-moving liquid. Drops from a funnel occur only once every 8 to 13 years, making it a symbol of extreme patience and scientific persistence. 4 decades, drops fell unnoticed, missing being captured, until 2013, when one was finally recorded. The experiment illustrates viscosity, showing that materials aren't always what they appear. Pitch is 200 billion times thicker than water, challenging our assumptions about the states of matter. There's a similar pitch drop experiment in Ireland that successfully recorded a drop in 2015. These experiments endure not for dramatic results but to remind us of the beauty in observation, patience, and the long-term nature of discovery. Another stunning tribute to time is the clock of the long now, a real clock designed to tick once a year and chime every 100 years, built to last 10,000 years. Conceived by Danny Hillis, it encourages long-term thinking in a short-term world. Together, these experiments show that time, patience, and curiosity can reveal truths that rush cannot. Even in silence, science speaks, if we're willing to slow down and listen. Mantelpiece clock. Imagine a clock, built not for hours, but for 10,000 years.
No batteries.
No digital parts. Just pure, ancient mechanics, hidden deep inside a mountain in West Texas. It doesn't tick every second. It ticks once a year. It chimes once every century. And in 10,000 years? It will deliver a cuckoo for the ages. This isn't science fiction. It's real. It's called the Clock of the Long Now, a bold vision by inventor Danny Hillis and artist Brian Eno. Built to last millennia, it challenges us to think bigger, slower, and far beyond ourselves. Built to last millennia, it challenges us to think bigger, slower, and far beyond ourselves. No plastic. No oil. No dependence on fragile tech. Just precision-engineered metal and stone, powered by you, the visitors who hike through a desert, climb a mountain, and win the weights by hand if no one visits? The clock simply waits. T doesn't track minutes, only the year. Its chimes, composed by Eno, will never repeat for 10,000 years. Each day, a melody the world has never heard before, and never will again. But the real magic, it's not just a machine. It's a message, a reminder that we are part of deep time. That the future matters. That what we build today can echo far beyond our own lives. And while this silent marvel ticks beneath the earth, another quiet science watches time in its own way: dendrochronology, tree rings. Organic clocks that whisper secrets of ancient droughts, volcanic winters, and sunlit years long gone. Together, the clock and the tree teach us a truth. Time isn't something we race through, it's something we grow with. So next time your clock rushes you, remember the one that's waiting. Still. Silent. Eternal. And it's ticking, just for you. Imagine holding a piece of wood that remembers the year 863. No screens.
No scrolls.
Just tree rings, nature's silent storytellers. Each year, trees record the climate in fine, quiet lines. A wide ring? A year of abundance. A thin one? A year of hardship, drought, or volcanic ash. Through dendrochronology, the science of tree rings, we've unlocked time itself. By aligning rings from living trees and ancient wood, scientists have created climate records stretching back 11,000 years, before writing, before agriculture. Take the bristlecone pine, a gnarled old sage standing 4,800 years tall, still alive. It began growing before the pyramids. Each ring? A heartbeat of history. And it's not just about age. These rings reveal past climates, volcanic eruptions, and even the chilling Little Ice Age with eerie accuracy. It's slow science, passed from teacher to student like a torch. No explosions, no labs humming with machines, just forests, patience, and a quiet reverence for time. And when we want to go deeper, millions, even billions of years, we look to the atom. Collision radioactive decay unfolds like nature's slowest clock. Some atoms are restless. Over eons, they transform, carbon into nitrogen, uranium into lead. By tracking this decay, we measure not decades, but planetary lifetimes. Radiometric dating lets us timestamp ancient rocks, meteorites, and even moon dust. That's how we know Earth is about 4.5 billion years old. Not a guess. Not a myth. Just chemistry, measured in atoms that have been quietly counting down for ages. So whether it's a tree silently remembering a cold spring in 1380, or an atom whispering the age of a mountain, one thing becomes clear. Hourglass not done time is everywhere. Written in bark, in stone, in the stars, and if we slow down enough to listen, it will tell us everything. Collision beneath your feet, time is ticking, in atoms. Radioactive decay isn't just how we date ancient fossils or rocks, it's the engine that keeps Earth alive. Deep within the planet, elements like uranium and thorium slowly break down, releasing heat. That heat drives plate tectonics and volcanoes. Without it, Earth might be a frozen, lifeless shell. Now imagine this. Test tube in a uranium mine in Oklo, West Africa, scientists stumbled upon something extraordinary in the 1970s, a natural nuclear reactor, 2 billion years old. Yes, long before humans built power plants, the Earth ran its own fission experiment underground, fueled by rainwater, rock, and time. It ran off and on for hundreds of thousands of years. That discovery didn't just amaze, it helped us understand how to safely manage nuclear waste over geological time. But the story of decay doesn't stop there. In the far reaches of space, radioactive isotopes light up distant stars and nebulae. They whisper the ages of stars through the slow fade of thorium and uranium, cosmic clocks ticking in silence. Earth, radioactive decay powers not only cities, but also dangers, nuclear weapons and hazardous waste. Which is why we're carving vaults into ancient rock, hoping they'll stay sealed for millennia. Yet even that isn't the slowest science. In Antarctica and Greenland, scientists drill deep into ancient ice, extracting cores like frosty scrolls. Layer by layer, they reveal secrets, air bubbles from 800,000 years ago, volcanic ash from forgotten eruptions, even pollen from vanished forests. 1 ring equals 1 year. 1 layer of ice equals 1 winter's memory. Together, radioactive atoms and ancient ice offer a shared lesson: time is always speaking. Sometimes through a whispering atom. Sometimes through a frozen breath. But always, always unfolding, if we're patient enough to listen. Absolutely. Here's a powerfully compressed and cinematic voiceover script, crafted to capture the mystery, tension, awe, and emotional impact of your original text. This version is ideal for a documentary, YouTube essay, or educational video intro with suspenseful visuals and ambient music. As the world heats up, something ancient begins to melt, not just ice but memory. Glaciers, formed over tens of thousands of years, are vanishing in mere decades. Locked inside them are secrets, stories of climates, disasters, recoveries. And with every drop of meltwater, those stories are being erased. That's why scientists are racing the clock, carving frozen time capsules and storing them deep underground, cryogenic libraries for a future that may need to remember what we forgot. But the tale doesn't end in ice. It's written in your DNA too. Every cell you carry holds the imprint of evolution, a molecular clock, ticking softly through time. From mitochondrial Eve to the wolves that became dogs, to Neanderthals who left in our genes. And it's not just us. Some microbes wait for millennia. Tardigrades, the indestructible water bears, survive boiling heat, freezing cold, even space, by pausing life itself. So what else might be waiting? Under Martian ice? Beneath Europa's crust? The Earth, and maybe the cosmos, is filled with life that remembers, adapts, endures. You don't need to hold an ice core or peer into a microscope to feel it. Just look in the mirror. Behind your eyes is a code written across billions of years. A quiet experiment still unfolding, one mutation at a time. The story of life isn't fast. It's slow, steady, ancient. And you're living it. Beneath our feet lies a hidden army, microbes largely asleep waiting. In soil, up to 90% of microbial life remains dormant, alive but paused, waiting for rain, sunlight, change. They're a microbial seed bank, a standby squad ready to revive ecosystems after droughts, fires, or human upheaval. But dormant microbes can also hide in plain sight, evading antibiotics. Diseases like tuberculosis can lurk silently for decades before reawakening. Decoding dormancy at the cellular level could revolutionize how we treat stubborn infections. Now picture this: microbes that have weathered millennia, frozen, patient survivors. What if we harness their resilience to preserve vaccines, or store genetic material, or even support life on long-duration space missions? Because sometimes the most powerful strategy isn't action, it's waiting. There is true poetry here. In our fast-paced world driven by speed and efficiency, these tiny organisms remind us, survival isn't always about thriving. Sometimes, enduring is enough. Deep beneath Antarctic ice, a drop of meltwater trickles into a crack. A microbe stirs, frozen for thousands of years. It rehydrates, revives, divides. One becomes two. A colony.
No fanfare.
No spectacle, just life reminding us it never truly died. It's a quiet reversal of time, a gentle unfolding where death and life blur in slow motion.